Hi, everyone. Welcome to another Build Hour. We are super excited to have you here with us today. This is a special edition Build Hour. I feel like our designer should have put some confetti or something on this slide, but today is going to be all about fine-tuning our newest model, GPT-4o Mini. Now, if you're here with us today, you are probably already fine-tuning GPT 3.5 Turbo or starting to explore fine-tuning our newest model. So today's session is going to get a little bit more in the deep end, a little bit more in the weeds in the demo. And as always, we will be here in the chat to answer your questions as we're going through the content. My name is Sarah Urbonis. I lead startup marketing here at OpenAI, and I'm joined by Noah.
Hello, Noah here. I'm a solution architect on our startups team. I'm really excited to be digging into the demo with you today.
Now, we always like to start with the goal of Build Hour. Here on the next slide. And that's really to empower you with the best practices, tools, and AI expertise to scale your company using our APIs and models. Now, again, this is going to be a little bit special today, getting a little bit more in the weeds because we have this new model that we're excited to get you all up and running on. So GPT-4o Mini is making cutting-edge intelligence even more accessible to all. This is a really great opportunity to really fine-tune your models with more performance and cost savings than we've offered in the past. So Noah's going to be kind of going through a high level of what 4o Mini offers, and then getting deep into the weeds of how to actually fine-tune it for your specific use cases to maximize the benefits of it. Now, in the next hour, as I mentioned, we'll have a lot of demos. We're first going to cover background, so GPT-4o Mini fine-tuning and distillation. If you are here, you should have some context around fine-tuning. Like I said, most of you are already doing it. So we're not going to cover fine-tuning so much as really the distillation process for you to maximize it even further. Next, we're going to go into a demo with a real example of routing customer service tickets to the right team. And we have a pretty bullish prompt today that Noah is going to walk you through with some really great impact and savings. Next, we're going to show some early signals from a couple customers that we work with, Superhuman and Ramp, and their early use cases fine-tuning 4o Mini. Finally, as always, we're going to wrap with Q&A. Please use the chat function to ask questions. We have our team here who's going to be helping answer your questions, and then we'll have Noah answer some live at the end. And I know one of the questions that always comes in before we start is, will this recording be shared out? Yes, it will be shared out. We're also going to drop the code repo into the chat now, so you can follow along as we are going. With that, pass it off to you, Noah.
All right, thank you very much. So let's dive in. And great. So let's get a little more in depth into 4o Mini. So you're probably familiar and pretty excited. I know I am. It's a lot more affordable, 80% cheaper than GPT 3.5 Turbo. And especially compared to 4o, it's just a super, super low cost model that's still really surprisingly intelligent. Longer context windows is also something that's pretty underappreciated, both on the input being 4 times longer and the output, the output being 4 times longer and the input being 8 times longer. A lot of really useful scenarios open up as a result of this. And again, those capabilities are really amazingly high intelligence model in 4o Mini. Now for fine-tuning specifically, you can extract as much performance for your use case as possible from this model. We're offering a program where training is free for the next 2 months. Very exciting. A couple caveats below, but yeah, definitely invite you to dive in and get your hands dirty with this model, especially for that period. And the same latency as the base model is also new. So 3.5 Turbo, when it was being fine-tuned, the fine-tuned model would actually operate a little bit slower than the base model, and we've fixed that with some really good engineering work. So what is fine-tuning good for? This is always important to remember that it's not one size fits all. It's very tempting to say that the model is not doing what I want it to, so I'm going to fine-tune it. And that's not necessarily the best approach that I would advise. A couple of the scenarios that it's really good for is adhering to format, syntax, or tone. A couple of the tasks that it really excels at is classification, entity extraction, structured parsing, and tool calling. And you can also obviously reduce latency or cost from using a smaller model that still gets to a pretty good performance benchmark relative to what your business might need. And you can also, it's an interesting one, reduce the token usage where you can have very long prompts in the training run and then reduce the number of tokens at inference time and save some costs there. Now, things it's not as good for. So teaching the model new knowledge. It's not great for, let's say I have 5,000 entities and I just want the model to be able to have it at its fingertips. I would use RAG for this. It's going to be a lot more reliable for this application. It also comes at the cost of generality, excuse me. So instead of the model out of the box being able to do anything, it kind of teaches it to forget most other things and do really well at one thing. So don't try to make it do multiple unrelated tasks. And then again, adding knowledge is not that well suited for fine tuning. So don't rely on it to sort of update your the content in the response. Great. So what is distillation? It's a little bit of a fancy term. In general, distillation just refers to having a sort of teacher model that's smarter and a student model that might have less knowledge or less capability, and use the teacher model in some way to extract as much signal as possible that can go into that student model and help it perform better. Now, one really basic version of this is, let's say use GPT-4o to do your classification, output the answer, and then fine-tune the smaller model on that answer. And well, that can potentially work to some extent. Doesn't give the smaller model 4o mini in this case very much signal as to how it should be making that inference, and the results I anticipate will be more limited. Now, what you can do better to get more signal out of GPT-4o is to add chain of thought. Not only here's the answer, but here's how to think about the answer, so that if you encounter in the future some subtle sort of changes or a slightly sort of related case, the model will actually grok the underlying thought process and will have a better chance of succeeding. However, if we just ask for 4o for the answer, it can actually be wrong. So what we're going to go through today is sort of an even stronger version of this, where we ground GPT-4o in a correct answer with that reasoning, and then use that as signal to sort of fine-tune and distill GPT-4o mini. All right, so let's get into our scenario. So we are using a sort of hypothetical that's very similar to how real customers are using this model today. So here's a very technical product, Nile Cloud Inc., and they are providing a variety of technical products to their customers. And we need to help them automatically triage customer service tickets. Before they're working with OpenAI, they did this entirely with humans. And they had a specific human that would triage the tickets one at a time. Now, they're pretty scaled. I'm assuming about 1,000 tickets per day, 2 minutes per ticket, and $60 an hour. That's actually close to $700,000 a year. Quite expensive. Now, previously, they started with the most capable model to try and do this as well as possible, which is my recommended starting point. Try to bound the problem, try to do as well as you can before optimizing for cost. And GPT-4o is very performant at this task. It successfully triages over 80%, roughly 80% of the tickets, which would equate to about $550,000 a year of savings. However, they are spending a lot on the OpenAI API to the tune of about $50,000 per year. So can we get the same performance with a 10x cost reduction and get their API bill down to $5,000 per year? That's our challenge for today. So just getting a little bit more in depth into this sort of triage step, this is very common across a bunch of different customer use cases and applications. So it's a really good sort of archetypal problem for us to look at. So here's the example. Someone's asking about queries taking longer to execute. Sometimes they time out. Also seems load related. The triage agent would not only say this is technical support, but there's a specific sort of database team that should be getting this ticket. And in this example, we have, I believe, 11 classes that we can choose from that have very subtle distinctions between them to make the task a little bit more challenging. So let's go through the entire step-by-step before we go into the code, we really need to align on the major sort of chunks of work that was done here. So the first is actually generating a data set. I actually looked for open source data sets for a number of hours and didn't find many that had the quality that I was looking for. Oftentimes the labels are wrong. Sometimes the inputs are actually very sort of limited or doesn't give the model any sort of signal to go from. So I decided to synthetically generate a high quality ground truth data set using GPT-4o, and we can get into the details of how to do that well. That gives us our ground truth samples that we can use downstream. Once we have our really good sort of eval data set, we split it into a subset that we want to use for training the model for distillation. And what we can do with that is give GPT-4o the input and the answer and say, as a hint, and say, please think step by step about how to arrive at this answer and then output that answer. And then we have our sort of fine-tuning training data. Then we actually do the fine-tune with 4o mini, given this input, think step by step and classify. And then now we have a 4o mini that is going to, again, think step by step and then classify the result on a new unseen sample. And we'll see how much it may or may not improve. So I want to go through a few of the prompts as well, because it's really helpful to have in your head exactly what we're asking the model to do. So this prompt has two elements I'd like to call out. The first is it's not only using chain of thought, but it's a very explicit form of chain of thought. So you're an expert at developing logical, rigorous reasoning to classify the intent of a customer service ticket. And in the analysis, there's 6 steps, one of which is to essentially look very closely at the salient details from the input, and then to think about how that compares to each of the classes, and then to reason about the final rationale, and then to output the answer. So it's very, very rigorous. It would be very boring to ask a human to sort of write an essay for each one of these, but the model really responds well to these type of very sort of verbose, high information chain of thought prompts. And then at the very bottom here, we give it a hint. And only for developing the training data do we add this, of course. We say, here's the answer, by the way. Please use chain of thought to arrive at this answer to make sure that we get 100% accuracy on our sort of fine-tuning data set. All right, deep breath. We're going through a lot here. So here is an example response with that chain of thought. So I won't go through every single aspect here, but some things to call out. Going through each of the possible classes, and you can see technical support database, actually, it gave it a sort of 9 confidence. Performance and latency issues, it's actually pretty related, so it gave it a 7, but there is some interesting sort of rationale as to why it is preferring the database team in this case. So this is a pretty complicated task for a language model to do. This is a perfect illustration of why 4o might outperform 4o mini off the bat. And also, this is extracting tons of good signal with which we can train 4o mini. Now, for the fine tune, it's important to call it exactly what's happening. So the way that it works is you upload a JSON lines file, we'll go into it, and each row has a system prompt that we went through as a user prompt that actually just asks it to do the triage. And then the output, the assistant prompt with the answer. And the assistant response is what the fine-tuning is actually going to be operating on. So 4o mini will the fine-tune at each step. We'll try and predict the assistant response. We'll compare it to the sort of label assistant response, compare the two, and then use that signal to improve 4o mini. And we'll have many of these lines. All right, let's dive into it. So how are we doing in time? I think we're pretty good. Let's get into the code. So, oh, perfect. So this is a live demo, so we never really know what's going to happen. I'll hit reopen here, hope for the best. And Great. So I hope that the code might have been sent out in chat. This is all checked into our GitHub repo. And we're in, just to orient you, the directory that says 3-4o mini fine-tuning. And we'll go through these files one at a time. So we'll start with generating our eval data. Close a couple of these, sorry. So I'm using Cursor. I'm a fan of Cursor, and I recommend folks try it. And instead of using Jupyter Notebook, VS Code/Cursor has this sort of inline evaluation. So I can run just this cell. I know not everyone's familiar with this. That will run this code and output the results on the right, just so that no one's confused. So let's walk through this step by step. So just defining a couple high-level parameters. We want 100 samples. We want to do one self-reflection loop. Stay tuned for that because we'll come back to it. Here is the system prompt. And this is a meta prompt that says, you are really good at generating evaluation data sets. Let me wrap those lines. And please take in the task definition and information about the task and generate a example with input and correct output. And we love chain of thought, so I also use chain of thought to outline the sort of thinking behind the test case. And now we go into the specifics for our actual task. So first step is to define the classes. And there are a number of them, as you can see. And you want to give the model as much information to sort of think about and chew on when it comes to making the classification. So I added a description and a couple examples as well to give it an idea of what to classify where. Okay, so there's a lot of information here. And then we'll go into the actual task. So this is similar to the prompt earlier, right? Customer service related chat. Sometimes can be very in-depth and long. Here are the classes. Oops. And then provide some information about the test cases, how to make them a little bit harder. And we can actually run this. And what's going to happen is we're going to call GPT-4o with these prompts, where every single prompt is inserted that sort of task definition. And we're going to run this in parallel. And then we'll get a sort of initial output of cases. Now, I always recommend starting out serially, but very quickly it gets really slow. So then parallelizing is definitely your friend when you're making a lot of LM calls. Now, if you're running a fair number of tokens, so I would encourage you to start with maybe 10 samples. For the sort of real analysis, I really, I think I used 1,000 samples, and it can get a little bit token expensive there. Okay, great. So I can actually output all cases. So let's just look at one of them. And exactly as expected, we have, here's a situation, here's the reasoning, and then here's the input and output. Great. Now, you might be asking, we're training models on output of other models. Is that an okay thing to do? Is that good? And the answer is models are surprisingly good at checking the output. They're better at sort of verifying whether something is good than doing the initial output. So I'm leveraging that to essentially generate the highest quality outputs possible with self-reflection. And you might think, if I was to sit down for 10 or 20 hours and make this data set by hand, that would be definitely the highest, probably the highest quality, although people get bored, they zone out. People are also not perfect. And then there's the first pass from 4o is maybe here. And with self-reflection, we can get a lot closer to sort of human ideal. And what I've done offline is look through the results for this and at least do a sampling and gut check that there's real signal, correct labels, etc. But there is a slight caveat here that it would be great if you had a fully sort of human validated data set for your own application. Great. So self-reflection says, here's a previous decision output, and consider whether, analyze whether it's correct or not, again, using chain of thought, and then output the correction if needed. And I won't spend too much time on this, but I've actually set it up so you could run it n times so that it can further kind of converge over time. I'll run this. And hopefully this doesn't take too long. And what we can see on the right here is the evaluation of this sort of self-reflection. So reflecting to correct logic and labels, we have 100 samples from above. So this is considering those samples, improving them, and sort of outputting them again. And we'll just wait a moment while this completes. Let's see, is there anything else I can highlight as we're going through it? And yeah, I wish that this, I can't hear anything from out there. So I don't know if there's an opportunity to pause, or I think my team will actually let me know if there's any sort of burning questions, and we can get to them at the end. Okay, so the model actually detected about 32% of cases were worth revising. So we've actually improved the data set to some extent there. And then what we're going to do is actually create the sort of final prompt. So we have inputs and labels. And then for future evaluation of the model, we just want a very simple task here. Triage the provided customer service chat, must select the single best category. Here are the classes, here are the chat. So this is what we'll ask the future model and see how it does. So I will go ahead. Yeah, I got a question. What's the mode that I'm running in Cursor, where the write code on the left side and execute it on the right? So this is actually a sort of VS Code feature known as VS Code Python inline. Yeah, if you Google those words, then this should come up. I think you have to install the ipykernel extension and then run a .py file with this little sort of hashtag %% character to define a cell. You should be good to go. It's really awesome. Cool. So here's an example, right? Since we've templated the prompt, there's a lot of text here, and we've saved the file to data, customer service, chat triage, and equals 100. So I've got a few here. You can kind of get a preview of some of the future files that we're going to be creating. And yeah, it's just a CSV with all the information that we expect. Great. So we've generated a synthetic data set, and this is actually pretty reusable as well. If you want to, in the future, add your own information to the task definition, then the rest of it should at least output a pretty good first pass. So let's move on to the next step. Let's actually run a baseline eval. How well are we performing without fine-tuning to see how much we can kind of improve? So I use PromptFoo for this, and I'd like to spend a little bit of time walking you through that. PromptFoo is a evaluation tool. It's open source. It runs the command line. Pretty lightweight, but also pretty powerful. And the way it works is you need to define a YAML file with a bunch of the following information. You can specify a couple prompts, specify a few providers, so 3.5 Turbo, 4o Mini, and 4o. And what it will do is evaluate sort of each of these prompts for each of these models. So this should output six test cases. And then for each of the tests, what happens is for all of the all of the rows in our CSV, essentially you can define a couple of these variables. The input variable is the prompt. The target variable is the correct output. And then those are actually going to be evaluated not only by feeding into the initial prompt, the output will be fed into this assert, which is a Python file, and that just extracts the text on the very last line of the output and compares it to the target. So that was a lot. Let's go through a couple of the prompts. So verbatim input.text is very simple. It's just you use the sort of double curly brace templating convention. So that will take over here this prompt sample, this whole thing, and just stick it in the first user prompt. Chain of thought, this is my third iteration of this prompt, takes the chain of thought we mentioned earlier. You're an expert at developing logical, rigorous reasoning to classify the intent, go through the following steps, etc. And then it adds this prompt to the user prompt. So this is sort of no chain of thought. This is adding chain of thought. And what we can do, let's just run it. All right. Now we generated 100 prompt food tests and saved it to this file. So what we can do is pop over to our terminal. And what we're going to do is do prompt foo eval. And then what file are we going to give it? We just generated 100 samples. And for the sake of time, I will increase the parallelism quite a lot. Let's say do it 50 at a time. Excellent. So how powerful is this, right? We are making a lot of LM calls simultaneously, testing all the combinations of all the information that we just showed. I will kind of pull up the YAML file. It's pretty hard to look at because it's a lot of text, but at the top, we just see our prompts, see our providers. We can actually go through that Python file in case we're curious. So you can, out of the box, give very simple sort of templated evals. In this case, I had to write a little bit of custom code, but it's super straightforward. It takes the output and compares the target variable to the last line of the output. And if there's a substring match, then return true. Let's go back to our terminal. And great, it finished. So now what we can do, so they have this kind of fancy table view, but what I prefer is to use their web viewer. So what you can do is, I've already sort of started the server, simply type prompt foo view, and then it will take all of the local data results and host a web server to sort of display them for you. And you can see that here. And let's make sure that we're getting the most recent test. I was a little worried that this would happen. I've run a lot of evals on here, so the database is slowing down a little bit. Let's give it maybe 5 seconds. Great. And okay, so hopefully we're on the same page. And we have 2 runs for 3.5 turbo with that verbatim prompt and the chain of thought prompt, right? And then we have both of those prompts for each of these models, 4o mini and 4o. And what we can see is, let's look at one of these inputs and outputs. So here's that entire input, and here is the output. And the target was performance and latency issues, and indeed it kind of got it right. And that's impressive because it didn't think about it. It just sort of spat out the first thing that occurred to it, and it got it right. And funnily enough, with all of this analysis, in this one example, it actually convinced itself that technical support database was a little bit preferred to performance and latency issues. But in general, we actually do see that the chain of thought with 4o is best. So that is exactly as expected. It's also a little bit surprising, but this is not the first time I've seen it, that 3.5 turbo gets a little confused with chain of thought, whereas 4o mini and 4o do better with chain of thought. Kind of interesting. All right, so let's go back to our code. So now we have a baseline. Sorry, just to emphasize, we want to do ideally as good as 4o with our 4o mini fine tune because it's much cheaper, right? Okay, let's do the fine tune, what we all came here to see. There's a lot of preparation. Close these windows. All right, so let's walk through a few of these parameters. So the run name, this was the file that we were generating earlier, and we're going to fine tune GPT-4o mini. And let's walk through it. So there's a little bit of prep to split the data into train versus test. I actually just sort of keep the indices in memory so that I can do the same split downstream. And then let's actually generate the data set. So this is quite an interesting step. We have our system prompt that we have talked about before, right? Go through these steps. And you're also provided with the correct output. And since the data was generated synthetically, I also add the sort of initial reasoning. So this is a bonus only for the generation of the labels. And then both of these system prompts are kind of appended. And then you can add the reasoning and the correct output from each row. And then we do a little bit of formatting. And then we go ahead and call the API to make a prediction based on all that information. So let's run these first two cells, actually the first three. And now we are generating those reasoning traces from 4o. Hopefully this doesn't take too long. All right, let's take a look at where we're going next. So now we want to take all of those reasoning traces, split them into train and test. And the fine-tuning wants both of these files because it will actually use the training files as examples to update the fine-tune model. And the test is the validation set that it can use as a holdout to make sure that we're not overfitting and that both of them are actually improving. And we love JSON-L as the sort of file format. And it's just a little bit of sort of output there. And then we're going to upload each of those files, the training file and the test file, to OpenAI, is the OpenAI client. And then we're going to kick off the fine-tuning job with each of those file IDs. Okay, so the reasoning traces have been created. Let's just take a little sneak preview. Messages. Yes. So it indeed does the analysis, and that's grounded in the correct answer. All right, let's do it. So we've saved the files. There's some JSON-L files up here. We're going to upload the files and kick off the fine-tuning job. Great. So now let's go into our OpenAI dashboard. And on the left, you can click fine-tuning. And then you can see my last one failed because I was just testing and it only had 7 examples. I'll refresh. And we can see our new job has appeared. And goes through a few steps, validates that the training file is the right format, etc. And then it just does some magic. And I really want to pause. This is usually requiring a machine learning engineer, maybe a scientist. It's very technical. It's very finicky to get this right. If you were to attempt to sort of fine-tune a open source model or a sort of self-trained model on your own. And it's pretty awesome that this is available fully via the API. It's super, super powerful. And we're seeing a lot of customers getting, honestly, pretty mind-blowing performance out of this when they are really figuring out how to use it well. So if we look at from a couple days ago, this does take some time. There's a queue. Again, it's pretty computationally sort of expensive. So here's a larger run that I did, trained on over 3 million tokens. And you can see that the loss is kind of improving over time. It's not quite converging as much as you might hope. Maybe we want to use a larger data set or more epochs to see this continue. It is overall a downward trend. And then it outputs this model. So let's go to the next step of the code, the actual fine-tune eval. And this is a very similar file as what we just saw, except we can add our sort of fine-tune model name. And what we want to do is only use the chain of thought prompt. This is another thing I'd like to highlight. you want the inputs into the fine-tuned model to pretty closely mirror, ideally exactly mirror the way that you trained it. So it wouldn't make sense to use the non-chain of thought prompt in this case. And aside from that, all this is the same. So I will go ahead and run this. Now we have a new prompt foo file. And since we initially had 100 samples and we did a 70%, 30% split, we only have 30 samples in our holdout set to do this evaluation. And we can go ahead and run another prompt foo evaluation. Just type it out for clarity's sake. And I've added this sort of FT. And again, let's do that 15 parallel. So I'm using the old sort of fine-tuned model. I hope I'm doing this right. And what we can do is actually skip to the results from the scaled up, because this is not going to be as meaningful with only 30 samples. But I've previously done this with 1,000 initial samples and 300 evaluation samples. And if we go back to the slides, so here's where we hashed out both. We care about performance, which we were looking at earlier, but also the cost, where the highest performing model is definitely 4o with chain of thought. Almost, and sorry, I hope everyone can see the screen. Oh, yes, I can. Slideshow. So 4o with chain of thought, as expected, is our highest performing model and our most expensive model. And in this case, especially because there's so many tokens used, it's over $10 per 1,000 requests, and they're doing, many more than thousands of requests. So this can really add up, as we saw. Now, 4o without chain of thought saves a bunch of tokens and is cheaper, but it's still super expensive. Look all the way to the left. 4o mini is much cheaper and also less performant as expected. So drum roll, when we actually add the distillation step, we get almost just a hair below the 4o chain of thought performance. I think it was like 80 versus 79% roughly, at a cost that is a little bit higher than 4o mini. But you can see that we're really advancing the frontier, where up and to the left in this case is really the direction you want to optimize. So this is a great result. I was a little bit surprised myself at just how capable this model was, and super excited to see. So this was not straightforward. You're seeing a very cleaned up set of code versus my experimental data set. I'll just kind of, don't want to voice over every step of this, but there's a lot of iteration on how do you get the best tokens and samples for fine-tuning? How do you even get the best data set? What is the initial sort of task definition and prompt? Going through the data is super important. Going through the failure modes. How do you define what the right kind of sort of hard even looks like for this task? One interesting thing I'd like to share is that if the task is too random, even though the initial models may not perform particularly well, if there's no signal, there's no information for it to learn, then the distillation didn't actually help, because the answer wasn't really knowable. It was maybe a toss-up between 3 different classes, and there's no way to know. So giving more task definitions, more information about each class really helped the chain of thought sort of sink its teeth into something. Cool. We made it. The code ran. Hopefully we learned a lot. Hope that was interesting. Now, I do want to highlight a couple examples of how folks are benefiting in the wild. Again, this has only been out for a very short amount of time, but I personally have been working pretty closely with Superhuman and really impressed with how well they've been benefiting from 4o and 4o mini fine-tuning. And what they saw was overall performance from 4o mini, especially with the fine-tune, is at least competitive, if not better than 4o. So that was similar to the example that we just went through. What good news, your OpenAI build just got slashed massively. And one interesting thing is this specific task, identifying the key issue in complex email threads, is actually hard. I had to spend on each sample, some of their sample data, quite some time sort of reading through and thinking it through step by step using chain of thought. So it's great to see that the model can do well in these kind of cognitively difficult tasks as well. RAMP has also been doing a lot of good work with 4o Mini. Both of these companies were featured in our sort of announcement blog post for 4o Mini. And this is more of a sort of data extraction task that we said earlier is likely well suited for 4o Mini. Good to see that play out in the wild. All right, we made it. We're at Q&A. I think pretty well on schedule. We've got about 17 minutes left. And I think my teammate Shamil will be replying in line, and I can try and answer some questions live as well. So the first one, in the example that I gave, we're training the student model to output the step-by-step thinking process before the answer. If the student model's output is customer-facing, and we wouldn't want a customer to see the intermediate steps, would we have to have a post-processing step to remove these intermediate steps? Maybe using some XML tags. 100%. Yes, you can essentially format the model's response in a number of ways. I like using JSON personally. We do have JSON mode. It can sort of enforce that you will get a valid JSON object out of it. And you might have the first key is reasoning and the second key is answer. You can prompt it so that only the answer is in the answer key, but it will still generate all those reasoning traces before. I have seen that without additional prompting for how to do the reasoning in JSON mode is a little bit less verbose. So maybe watch out for that. You can use XML tags. You can also use, as I was doing in the eval, just output the answer on the very last line, and then you can essentially split on new line characters and try to extract that as well. For a task that contains multiple steps to reach the final answer, what is best? Provide all the steps and examples for each step on how to think about that step all in a single prompt. Do step-specific LLM and provide examples accordingly in each LLM and aggregate the results. Yeah, interesting question. The first, kind of as a general principle, you want to start with a very smart model and a very large prompt. It gets complicated to try and coordinate a bunch of different LLMs, and they're all being coordinated in different ways. And think about what the performance can be there before trying to carve out, okay, this is a really specialized sort of initial task that I would want to separate and then subsequently combine. One thing that does come to mind could be if there's sort of raw information extraction, if it's a really, really messy input, maybe it's images, maybe it's PDFs. First, you'd probably want more specialized models to get the really good raw data, maybe format it in a way that is really sort of easy to grok and reason over. But the reasoning step itself is actually pretty complicated. There's a lot of referring, right? I'm going to output this, and then based on those, I'm going to make a new kind of conclusion. And I think that there's actually, this is just my gut, there's some benefit for the model having all of that context at once. So I would even lean in the direction of trying to do a good chunk of the chain of thought in one model. Let's see. What's the difference between this and doing chain of thought on GPT-4o Mini directly? Yeah. So we actually saw in some of the benchmarking that exact comparison. So 4o Mini with chain of thought is this dot got about 74%. And then with chain of thought and fine tuning got about 79%. Now, the reasoning for that is essentially 4o is smarter than 4o Mini. If both of them are told to sort of reason over and think step by step, 4o, since it understands more about the world, it has higher intelligence, so it can make better sort of inferences. It's just going to perform better at that. The reason for that is that 4o Mini is smaller and it can't quite fit as much into the limited space you might be able to intuitively think about it. And by using the reasoning traces from 4o, you're essentially dedicating more of the smaller model just for this one task. Again, at the cost of generality, it can say, I only want to do this thing well. And that's one way of thinking about how 4o Mini can perform better than it can out of the box. Let's see. Should the same model which generated the synthetic data be used for self-reflection corrections? Any benefit to mixing or using multiple? That is a great question. There are caveats for using models to reason over other model outputs. There's a lot of debate right now in sort of model graded outputs. Using a model to grade another model, you can say like, is this a friendly output? Is this a well-formatted output? Sort of high-level things, criteria that you might be trying to enforce. Those models, in that case, tend to prefer outputs from themselves or the same sort of class of model. And it could make sense in that case to do a mixture, do voting across multiple different models. That I think is an empirical question. It could be an interesting technical blog post in the future. As with many things, I would encourage you to try it and see what happens. And in this case specifically, try to use the human labels as the ground truth. So look at the self-reflection from 4o on 4o, 4o on another model on 4o, sample down to like 50 and see which ones you agree with the most. Cool. Should the same model which generated, oh, I just answered that. In some customer issues, one customer support chat could be mapped to more than one issue. What changes can we do in the current process to address multiple mapping of issues? We also use GPT to find the different categories of issues customers might be facing and map the customer chat to the found category automatically. Yeah, that's a really interesting. Sorry, yes, I should read the questions a little more clearly. So first question is, how would you expand this to operate in more than one class? So we actually, we can frame the task as a multi-class task for sure, where the output is output all of the most important tasks to take care of. From a sort of product perspective, arguably you would want you wouldn't want three teams trying to address it all at the same time. Maybe they're tripping over each other. It's hard to sort of maintain state. So maybe I would suggest trying to route it to the highest priority, even if there are multiple intents, and then passing it off for the lower priority tasks. But if you did want to do multi-class, yeah, the outputs, rather than one output, could be a list of outputs, for example. The labels could be a list of different outputs. We even saw in the chain of thought, there was some sort of confidence level, and sometimes there was like an 8 and a 9, and maybe it outputs anything that's above a certain sort of level of confidence. That could definitely work. As far as using GPT to find the different categories of issues, yes, I think that would be a fantastic sort of offline analysis to do, with the caveat that your system is going to be built in a pretty, rigid way around like, I have to spin up a different team or a different sort of linear queue, or right, you need to have the process on the other side of it to accept the classification that it outputs. And if you wanted to pause and say, do we have the right classifications? Should we be splitting these things into subcategories? You could definitely use something like 4o Mini to sample 1,000 of your tasks, give it sort of best advice as to what the class should be with no knowledge of your current ontology, and see where the gaps are. I think that would be great. How large was the final fine-tuning data set? Are there metrics for pure 4o Mini fine-tuning with no chain of thought? The final fine-tuning data set in this case was 700 samples for the input, 300 for the validation set. And yeah, so one sort of implied question here is, how much data should you use? And that depends on how difficult the task is. And empirically, you can kind of see how your performance trends based on different sort of data sizes. And even if you have 100 samples, you could train one on 50 and train one on 100 and see if the line is sort of continuing to go up. Maybe 200 would be helpful in that case. Or if it's kind of plateaued, maybe it's not worth continuing to scale up. So you have to play around a little bit there. And I definitely wanted to try more variations of what happens if you fine-tune 4o Mini without chain of thought. I anticipate intuitively that it would pick up on some interesting key words. Oh, they named a database, and that tends to be mapped to the database team. It still is worth trying, and might be beneficial. I just cut scope for the sake of the demo. Let's see. How does fine-tuning work with dynamic few-shot examples? The dynamic samples are fetched according to the input to have more relevant knowledge. Yeah, that is an interesting question. So we didn't explore few-shot here, but that is another sort of very tried and true way of further improving performance. One thing to keep in mind for fine-tuning is that all that really matters is if the distribution of the training set more or less matches the distribution of the real world sort of production use case you have. So it doesn't need to be like, right, we kind of hard coded the classes, but the input customer ticket is going to be different every single time. That also could mean that if you're dynamically fetching few-shot examples, that could change. And that's fine as long as the training data set is fetching similar kind of examples, right? Ideally, they're from the same corpus. You are exploring the sort of space of potential samples that you could be retrieving the real world. I would, if it changes languages in production or you're retrieving, 20 examples instead of 5, maybe there's ways that it would start to behave a little bit unpredictably. But it's kind of getting the distribution of, given this type of information in your few-shot examples, I'm going to be making this type of inference. I think that's definitely worth trying. Let's see. Could you tell us a little bit about the data distribution? Will you form the data set just from a uniform distribution of the labels, or would it be better to combine it with invalid cases or some unexpected inputs as well? Yes, this is a great point. We didn't look very much at the generated data set for the sake of time. There's 2 optimizations I would probably do. One is on the creation of the data set. I'm actually relying on the model to provide diverse inputs. I think in the prompt, I say, provide a range of potentially difficult examples. And I did observe that the class distribution, there was, a pretty good spread of classes represented. You can be a lot more explicit with that and say, here are my sort of 11 classes. I want, an equal distribution of each. And then in the prompt, I would probably say, in the loop, like, okay, these 10 are going to be this class, these 10 are going to be this class, et cetera. And then on the curation of the data set, there's this loop of look at the examples where the model is failing and try and use those to either inform the creation of new examples, or if you have a sort of production data set of hard examples, you do want to make it tough so that there's a hill to climb and you can extract signal. So it's fairly common to have like, here's my representative distribution production data. And maybe that has like 50% billing. And it's pretty easy for the model to even just guess 50% of the time that it should be billing. So that's like the simple case. And then you have your hard case, and then you have your super, super hard case with a lot of failures that explores, maybe you're doing data augmentation on a subset of like really sort of challenging cases. And then that's going to give as much sort of signal as possible for how to improve. I definitely encourage doing some kind of explore exploit in the data set to look at where it's failing and then add that to the data set and see if you can kind of improve. There's actually some automated ways of doing that as well, which is out of scope for right now. Okay, I will answer 2 more questions before we wrap up. We're getting pretty close to the top of the hour. Have you seen issues with overfitting where a fine-tuned model parrots particular aspects of training examples, but gives quirky answers for new inputs? Interesting. So I personally haven't seen this. I could speculate as to what might be going on. So the parroting could happen for 2 reasons. Potentially, you have many examples in your training set that have that exact input and or that exact output. And the extreme version of this is you have 100 different inputs and the output is always yes, then it's probably just going to learn to always output yes. regardless of the input, right? And there's sort of more sort of constrained local versions of that where it learns for this class of thing, like I should just always output this. So I would pay close attention to the training data. The number of epochs also kind of bakes in the distribution of the training data even more. So one nice lever, if you have super structured, super consistent outputs, maybe run more epochs, but in this case, if you want a little bit more diversity, maybe back off the number of epochs and see if that helps. And quirky answers for new inputs. Again, I would think hard about the distribution of the new inputs. If it's like in the in the ballpark of the training samples, then I would expect it to behave a little better. If it's very different from the inputs, then you're in a little bit uncharted territory. And even more, you can kind of think about like the initial model is trained to only do a certain set of things and not sort of assume that it can do new things, new unexpected things. Fine-tuning breaks that a little bit and says, here's all these unexpected new things that you can do. And there's a chance that it can go a little bit too creative as a result of that. Okay, last question. Cogen wasn't mentioned as a good use case for this. Is there a cogen use case of fine-tuning GPT-4o mini? Yes, it depends. Cogen, in the hardest case, is going to be very challenging and require very general intelligence, right? If you're trying to replace a junior software engineer, there's a lot of inference, a lot of sort of difficulty associated with that task that it would be a little hard to even think about how to construct a fine-tuned data set that encompasses all tasks for coding. And there are some coding tasks that are very specific, very constrained, very fast, very predictable. And I don't know, maybe something like GitHub Copilot, right? If you're trying to autocomplete a for loop and then you kind of define the variables and then it reads the comment and kind of gets what's coming downstream, there is a chance that fine-tuning would be good for a kind of constrained version like that. Cool. So we are almost there. I will do. All right.
We'll close us out. So
Yeah.
thanks, Noah. I will also mention Noah joined OpenAI, like a month and a half ago. So kudos to you for doing a full hour of this brand new model that is hot off the press.
Thanks for having me.
Of course, there were some really great questions that came in. So as always, we are going to share out the recording with you all, as well as these resources. There was also a question about the prior build hour on fine tuning. We'll send out a recording to that as well, because I think that's kind of like good intro material.
Definitely.
And then we'll also share the follow-up survey. This is a great opportunity to share what you want to see in future build hours. And there's also a question in there for feedback around 4o mini that we'll actually share with our engineering and product teams. So if you have any additional burning questions, kind of product feedback as you're going through fine-tuning, definitely let us know. We would love to hear from you.
All right. Thanks, everyone.
Thanks for joining.